Okay. Number 4, everybody's favorite, the piecewise graph. Very similar to the one that we did on the quiz last week as well. It's only a linear function. And here on this one, you're doing it from 0. 0 to the left, 0 to the right for each individual function. All right, then you got your operations. You got your add, subtract, multiply, and divide of functions. One of the ones that was missed the most on the quiz is whenever you do subtraction, we have to make sure to put the x plus 6 in parentheses, and we got to distribute that minus sign throughout. Okay, and that's one way to do it. And then you would plug -4 in at the end. Or you could plug -4 in to f, you could plug -4 into g, and then you could subtract those two answers. So either way, also notice that when we have an x squared, we want to make sure that when we square that -4, when we put it into our calculator, we put that -4 in parentheses. Because if you don't put that -4 in parentheses, then it will not treat it the same way. So you got to make sure you tell your calculator exactly what to do. And for most of your calculators, you got to put that in parentheses. Okay, on number 8, this is a domain question once again. We have f divided by g. So we're going to put f on top. G on bottom. And we talked throughout the chapter, whenever we do domain, there's two things that we really got to watch out for. We got to watch out for denominators. We got to watch out for radicals. This one has both. This one has a denominator and a radical. The radical is in the denominator. Okay, so both things are actually happening here that we have to watch out for. So we can't have 0 on bottom, right? And we also want to know what is going to make this expression negative, because we can't have a negative under the radical. And so the way that we're going to write this is that x plus 4 has to be greater than 0. It can't be equal to 0 because we can't have 0 on bottom. Typically when we would do this, we would say greater than or equal to 0, but we don't want it to equal 0 because we can't have 0 on the bottom of the fraction. So we're just going to say x plus 4 is greater than 0, and then we got to figure out which values of x make that happen. So it'd be x is greater than -4. And then your 4 answers are written in interval notation. Okay, here's another difference quotient problem, and once again, just remind yourself that difference quotient means slope. So it's just a real fancy way of saying what is the slope of this function that we're given. And the only thing that I've given you is linear functions. So I'm not going to surprise you on the test tomorrow and give you something else. That's the only thing we've done. So right now, you just have to know how to find the slope of a linear function, which should be a piece of cake. You don't have to show work. On my key, I showed work. I showed how to use the difference quotient, but you don't have to do all of that. So if you looked at my key tonight and are wondering if you have to do all that, you don't. Just tell me what the slope is. Okay, remember these are the composition ones. We just read that as f follows g of 7. So we plug 7 into g, and then we plug that answer into f. So we're going backwards. And your answer is a value, a number. On number 11, it would be an expression, because we're not evaluating it for a certain number. So that just means we're going to take f of x, plug it into g, and determine what the new expression is going to be. Okay, on number 12, we're doing composition, okay? So I'm going to plug G into F. But it's not just asking me to find F follows G. It's asking me to find the domain of F follows G. And we have a radical, right? And so what do we know about a square root? What numbers can we not have? Negative. Okay? So kind of like the one we did a few minutes ago, we're going to say 2x plus 6 must be greater than or equal to. This one we're going to put equal to on it because it can be 0. Okay? It couldn't be 0 here a second ago because it was in the denominator. On this one, it's not in the denominator. We don't have a fraction. So this one, we could have it equal to 0. So 2x plus 6 must be greater than or equal to 0. And then we're going to solve for x. What values of x make this true? We just got to finish it out. Okay, but we don't just want to say -3. What would we say? We got to write our answer as an involved. Okay, 13, we had one like this on the quiz last week too. A couple of ways that you can do this. The x-axis is the opposite of y. So you can just remember that when it's symmetric to the x-axis, we just do the opposite of y. Or 7-2 would be up here. And if I flip it over the x-axis, it's going to end up down here. And that's the point we're looking at. And out of all of these, there's only one point out of all of these that would be in this quadrant down here. We have to go right and we have to go down. And so this would be the only one. But the other thing that we did was we just did the opposite of y. So we just changed the sign on 2. Okay. So either way you want to do it, if you're more like a visual person like we talked about, you can draw a little picture and then flip it over the x-axis, or you can just remember the little rule that it's the opposite of y. If it's y-axis, it would be the opposite of x. If it's the origin, it would be the opposite of both. Okay, 14, and the directions here are not, don't pay attention to this stuff like on it's just part of the test generator that I use. All I want to know is, what would I have to do to get to this graph from the original graph? Okay, and so you're going to answer it over here on the blank and tell me what is happening. Okay, what kind of movement, what kind of change is taking place? And so you just tell me what's going on. And there's really two changes here. The 6 and the 2 are both doing something to that graph, so you have to tell me what's happening. On number 15, I'm just going to show you kind of a trick here. Because this is multiple choice, try to make this as easy as possible because there's several things going on in here. You got a 0.8 out in front, you got a negative x on the inside of the absolute value, and then you got a -4. All of those things are changes from the original function, okay? The easiest one out of all of those, I think, and I think you guys probably will agree, is the -4. What is the -4? Tell me. Down 4, okay? So I'm just going to kind of go through and process of elimination. I'm going to see which one says down 4. Well, A says 4 units down, okay? So that one's good. B says 4 units up, so B is out. C says horizontal factor of 4, not true. D says 4 units to the right. So, process of elimination. The only one that really works was A, and all I did was look at one change. Now, are the other 3 changes talked about here? Yeah, because it reflects across the y-axis because of this negative right here. It's a vertical shrink because of the 0.8 out in front. So all of those changes are taking place. But pick out the one that you think is the easiest to determine, and then I think it's easier just to kind of use a process of elimination. to get you where you need to be. Okay, 11 is kind of the same way. Okay, on 17, I want you to graph both graphs, and it tells you that in the directions. Graph the basic function, and because this is absolute value, the basic function would just be the absolute value of x. And you're going to do that with a solid line. And then you're going to do y equals -4 times the absolute value of x with a dotted line. So you just graph in two graphs. And the reason we do one solid and one dotted is to show the difference between the two and showing what changes take place. Okay, and when you graph it, make sure, like in this case, one's going to be skinnier than the other. So you got to show that one's going to be skinnier than the other, and you got to decide which one that's going to be, and then show that on the graph. You don't want to show them both being the same width, because that's not what's going on here. You don't have to be real particular with your graph here, but you do need to show both graphs, and you need to show kind of the difference between. And it probably wouldn't be a bad idea to just describe the change that took place. What did the -4 do to the graph? Just so your graph matches up with your description. Okay, 18 and 19 kind of go back to what we talked about with all the different changes, okay? And we did a couple of these together last week, and we had some like this on our homework from this section. F of x minus 1 would do what? If g of x is my original graph, what would f of x minus 1 do to my graph? No matter what the function is. Down 1, okay? Because it's at the end. It's after the function. It's not inside the function. So it's going to shift it down 1. If a graph or a point shifts down 1, which ordered pair is being changed? The y value. So originally it was at 21, and if I go down 1, it would now be at 20. The x value is unchanged. So 820 would be our new ordered pair. So try number 19. Just remember here, the f of x is really thought of as y, and that was kind of a trick I taught you last week to kind of think about. So when I am applying it, I'm applying it to the y value when I see f of x like that. 20 is another one. This one's kind of the opposite of what we did just a few minutes ago. This one describes all the changes, and then you want to describe or write the equation that matches up with that, okay? So it just kind of does it in a different order. Once again, pick one that's really easy. Like for instance, 9 units down. That should be able to, and then you may not be able to come up with your answer here because 9 units down, I got 2 of them that show me 9 units down. So now I've reduced my choices to either A or B, and then I got to look at another change. Okay, reflect across the y-axis in a vertical stretch of 1.1. So we got to decide which one gives me that. So try to make those as easy as you can. Okay, process of elimination kind of thing. Okay, 21 is just a matching, okay, or a multiple choice. When I have x plus 2 on the inside of a function, what direction is that going to shift it? Left 2, okay, because it's on the inside, okay? And so, you don't necessarily have to write this here because it's a multiple choice question, but I'm going to write left 2 here just so I know that I'm moving my graph left 2. And then I'm going to pick a point. Okay, 0, 0 would be a really simple point to use. 0, 0 is taking that middle point and moving it over to -2, right? So the middle of the graph is going to land at -2, and so the only one that would make sense then would be C. And you could do that for any point that's on the graph. I could take this point here, which is at 2, 4, and I could move it 2 units to the left, and so now it would be at 0, 4. I could take this point and move it 2 units to the left. Any of those points should be okay to move, okay? We're moving all of those points left 2, so it doesn't matter which one I choose. And you could do it to all of them if you really wanted to, but you don't necessarily need to do all. Okay, and then from 22 on, these are the ones that we did yesterday. Okay, so we got a lot of different variation questions on here. I'm going to put the 3 variation formulas up here. And remember, these are just your generic variation formulas. Sometimes these are going to use different variables than what we have here. Okay, so I'll leave those up on the board tomorrow, so you'll have those to kind of go off of, but you just have to kind of use the variables that you've got. All right, so let's look at number 23. Inverse as x means y equals k over x. That's my original equation. So I'm going to plug 54 in for y. I'm going to plug 1/9 in for x. Okay, what would I do to get rid of the 1/9? Yeah. So I could either divide by 1/9, okay, or multiply by 1/9. But if this was just a 9 down here, I would just multiply by 9, right? Because it's on bottom. So I'm going to multiply by whatever number's in the denominator here. Okay? So we're going to multiply by 1/9 on both sides. Okay, and what it's asking for here is what's my equation of variation. So I'm going to plug that back in, and that would be my equation. Y equals 6 over x. That's as far as we're going to go on those. There's going to be a few that are going to take it a little bit further than that. But on that one, that's as far as you need to go. Okay, let's look at number 24. This one is we did some story problems yesterday as well. This one kind of gives us an example of a story problem. We're going to find that variation equation, and then we're going to plug it back in to find out a value. Because if I look at my 4 choices here, they're all a value, right? They're not an equation. So we got to use the equation then to evaluate it. G equals K times T. The gears, the number of gears, G, varies directly as the time that it operates. And then it tells me in the first sentence, if it can make 6,044 gears in 17 hours, first thing I got to do is I got to find my K value. So we're going to divide by 17. Now, if I divide 6,044 by 17, does it come out to be a nice whole number? No. Okay? So here would be my recommendation. And this, I had several people yesterday ask me about this on the homework. When it gives you this big long decimal, or even a repeating decimal of any kind, don't change that decimal, right? We want our answer to be as exact as possible. So I'm just going to leave it as a fraction. If I can reduce it, I would reduce it. But if I can't, I'm just going to leave it as this fraction. And when I plug it back in, I'm going to, or just leave that number in your calculator. You could do that as well. And then we're going to multiply it by 2. Because we want to know how many gears can we make in 2 hours. So I'm trying to solve for the number of gears, and I'm going to plug 2 in for my time. So don't freak out if it doesn't come up to be a nice whole number for your K value. What do we get? And then the last one I'm going to do with you is number 27. I didn't do an example of one of these yesterday with you, but there was some like this on your homework, and we talked about it when we did the notes. It's not a whole lot different than the ones we did, except for one word. We have a square in this one. So you got to really read it carefully as you go through the statement. And this one is joint and inverse. So this one is two different variations that are happening. So you're going to combine those together into one equation. Y equals K X P, and then inversely means I'm going to divide the square of S. Don't forget about the square. First step is to always write that function out, that new variation equation. Then we're going to plug in the numbers that they give me to find out what K is. So 9/2 is Y. K times 1 times 9 all over 4 squared. Okay, so this is really 16 on bottom, right? I want to get rid of that fraction first and foremost. So what I'm going to do is I'm going to multiply by 16 on both sides. You could do 16 times 9 divided by 2, or what I like to do here is 16 divided by 2 first, which is 8, and then 8 times 9 would be 72. And then 9 times 1 is still just 9. And then 72 divided by 9 would be 8. And that would be our K value. Okay? So we got to do all that work to find out what our K value is. And the question is asking us to write the equation of variation. So we're going to write the function, or the variation equation. We're going to go back to what we have here. We're going to rewrite this exactly the same way, but we're just going to insert 8 for K. So 8xp over s squared. And that's our variation equation. You don't have to do anything else with it. Okay. I'm going to let you guys work. If you have questions, let me know.